In this video, we're going to solve the following problem. Suppose you drop a rock from a height of 100 meters. How far does the rock travel in the last 3 seconds before it hits the ground? Now, in order to solve this problem, let's consider all the information that we have. So what do we want? What do we know? What do we need? Okay, well, we need to know basically how far the rock falls. So x for rock over the last 3 seconds, right? This is important because what we really need to know as an intermediate step is to know the total time the rock takes to fall. So what we really need is the time for rock to fall. Okay? So what do we know? Well, we know that the height is 100 meters, right? What else do we know? We know the force of the acceleration due to gravity is 9.8 meters per second squared. Okay, so let's draw a picture of this. So the rock will fall 100 meters. So the rock will fall from this height. This height right here is 100 meters. Okay, now this will take a certain amount of time that it will fall, basically. So it takes time t, right? And we're just concerned about basically the last 3 seconds. Okay, so this is the height goes over last 3 seconds. Okay, so let's try to solve. So let's solve for the time first, right? So remember that in this case it'll be delta x is equal to basically well, okay, let's write it down. So x is equal to the initial position I, so x final, so x initial plus v initial times t, right, plus 1/2 at squared. Okay, all right. For convenience, what we're going to do is we're going to actually just basically consider the directionality of everything. So let's select basically this be the positive x direction. Okay, all right. So in that case, basically g will just be. So in that case, what you'll get is basically, and also let's let this point be x equals 0. Right. So we know the initial position is x equals 0. So final position is equal to 0, right, plus basically v initial t plus 1/2. Now a is going to be g t squared. Okay, we also know the final position. The final position is down here, which is 100 meters down. So in fact, this is 100 meters. Okay, all right, and we also know one more thing. We're dropping the rock from a height, okay, which means that v initial here is equal to 0. So in fact, this is equal to 0. Okay, so this is actually very simple. 100 meters is equal to 1/2 gt squared. Okay, let's plug in numbers now. Okay, we'll solve for t now. So plugging in numbers is 1/2 times 9.8 meters per second squared times t squared. Okay, and when we do this out, what you will find is that this is equal to, this implies that t squared is equal to 20.4, which means that t is equal to the square root of 20.4, which is about 4.51 seconds. All right, that's great. Okay, so this height, this time it takes is 4.51 seconds, right? And we just care about the distance it falls over the last 3 seconds. Now, we can do this problem 2 ways, right? The first way is to basically figure out how far it falls to this position, okay? And then figure out how far this position is, right? Okay? But we know one thing. We know the total time it takes to fall is 4.51 seconds, right? And we care about what happens over the last 3 seconds. So over the initial time right here, it fell for basically 4.51 total seconds minus 3 seconds, which is 1.51 seconds. This gives a certain height. Basically, I'll call this, well, for lack of a better variable, y, for instance. Okay, all right. So this is the time it takes to fall distance, and we can compute this distance here. This is just going to be equal to 1/2 gt squared, because it fell from rest. There's no initial velocity. Okay, and for t, we plug in basically this 1.51. Okay, so we will solve for y. Okay, so y is going to be equal to, let's just bring it up. Y is equal to 1/2 times 9.8 times the total time it fell, 4.51, minus 3 seconds squared, time that we care about. And if we do that, what we'll end up getting is we'll get something that's 1/2 9.8 times 1.51 seconds squared, which if you plug in all the numbers is 11.2 meters. So this distance here is 11.2 meters. This distance here is going to be 100 meters minus 11.2 meters. All right? Okay, so now we can get to basically over the last 3 seconds. We get basically I'll call it the variable s, or actually let's call it, I'll call it s, is equal to the total height, which is 100 meters, minus the height which it fell over the first 1.5 seconds, such that it makes the rest of the time fall to be 3 seconds. And this distance is 11.2 meters. And so when we plug it all in, this is 88.8 meters. And we're done. Beautiful. All right, hope that was helpful.